So now we are going to be looking at the sine and cosine and the tangent of 45 degree, 30 degree and 60 degrees. And these are called special angles. In a couple of minutes, I will explain why they are called special angles. So first we have a right angle triangle where our opposite side is given as 1 and our adjacent side is given as 1. So this is a unit triangle here. So we are not given the length of the hypotenuse here, but we can have our length using of the hypotenuse rather. We can see that the length of the hypotenuse can be gotten using c square equal to a square plus b square, where a square plus b square are just 1 plus 1, which is 2. So our c square here is equal to 2. Then our c, which is the side of our hypotenuse here, is equal to the square root of 2. Now, that is what we got from our basic knowledge of the Pythagoras theorem. Now, from here, using the SOHCAHTOA, the SOHCAHTOA, we can see that our sine theta and theta here is given as 45 degree, that our sine 45 degree is equal to the opposite over the hypotenuse. Now sine 45 degree is equal to the opposite over the hypotenuse, which has been given as the square root of 2, and that is what we see here. And also that our cos 45 degree is equal to 1 over square root 2, which is also the adjacent over the hypotenuse, and this is the same thing as the sine of 45 degree. And we can see also from here that our tan 45 degree is simply equal to 1, which is the opposite 1 divided by the adjacent 1. So 1 divided by 1 is simply 1. Now that is for the angle, 45 degree angle. What about the 30 degree angle and the 60 degree angle? In the To evaluate that for the 30 and 60 degree, we have an equilateral triangle with length of sides of 2 units each. So this has to be equal to this and has to be equal to this, since this is an equilateral triangle, although this triangle is not drawn to scale, but we assume it is an equilateral triangle if it is drawn to scale. So this is 2, 2 here, and also 2 here. And here you can see that I have drawn a line from the midpoint at this point here down to this bottom point here. And since I have done that from the midpoint here, this has been divided into 2 equal halves, which is 1 and 1. And also this angle has been divided into 2 equal halves. Now, how do I know that this is 60, 30, 30, and 60? Is because since it is an equilateral triangle, unlike this particular triangle here, which this has to be 45 degree, 45 degree, based on our knowledge of complementary angles, that complementary angles have to equal 90 degree. Now, so here, based on our knowledge of the sum of the interior angles of a triangle, which we know that the sum of interior angles of a triangle has to equal 180 degree. And so since this is an equilateral triangle with equal sides and also equal angles, this has to be 60, 60, 60, and that is 180 degree. So dividing these into 2 equal halves, I have 30 here and 30 here. And so if I evaluate one angle here, it's the same thing as evaluating the other angle at the same time. So here we can see that we have been given the hypotenuse and we have been given the adjacent. That is if we are working with 60 degree for now. We are going to come back to the 30 degree. Now working with the 60 degree, we have our hypotenuse here and we have our adjacent here. So we don't know our opposite, which is the same thing as what we have seen in the previous example here. We have the hypotenuse and we have the adjacent, but we don't have the opposite. So See, we use the same formula from the Pythagoras theorem, which is what we can see here. And so I have that my opposite here is equal to a square, and a square rather is equal to c square minus b square from the Pythagoras theorem. So taking the square root of both sides, I will have that the square root of c square minus b square is equal to my a, which is the opposite side here. And I know what c is, which is 2 and square. And I know what b is here, which is my 1. So 2 square is 4 minus 1, and that is 3. So I have this side to be the square root of 3. Now, evaluating the sine, cosine, and tan of my 60 degree here, I have that my sine 60 degree is equal to opposite over hypotenuse, and that is what we have just gotten here, that the opposite is the square root of 3. Now, sine 60 degree is opposite over hypotenuse. Opposite over hypotenuse. While cos 60 degree is equal to the adjacent over the hypotenuse, which is just half. And the tan 60 degree is equal to the opposite over the adjacent, which is the square root of 3, because root 3 divided by 1 is still root 3. And now for the sine 30 degree, which is up here, this becomes my opposite. So for my sine 30 degree, my opposite is 1. The side facing the angle is 1. And my adjacent, or rather my hypotenuse, is still the same. It doesn't change. So for sine 30 degree, my it is 1 over 2. While for my cos 30 degree, it is simply square root of 3 over 2, which is the adjacent over the hypotenuse. And for my tan 30 degree is simply the reciprocal of my tan 60 degree, and that is what we have seen here, which is opposite over adjacent. And now it is easy to evaluate, since if I know my sine 60 degree and my cos 60 degree, I automatically know my sine 30 degree and cos 30 degree by just switching both of them. And you can see sine 60 degree is equal to cos 30 degree, and cos 60 degree is equal to sine 30 degrees. And here also, we have tan 60 degree, which is simply the reciprocal of tan 30 degree. And the above is referred to as trigonometric special angles. And why are they called special angles? Because these are easy to evaluate without using a calculator. So if you even insert all these numbers into your calculator, they come out to become sine 60, cos 60, and tan 60. So same goes with the sine 45, cos 45, and tan 45. Inserting this into your calculator rather, you get these answers here, and that is why they are called trigonometric special angles. Now, these special angles can be represented in radians, and this is it, where 1 radian, or 1 pi rather, is equal to 180 degrees. So 180 divided by 6 here will give me 30. So pi divided by 6 gives me 30 degree. So another way of writing 30 degree in radians is equal to pi over 6. And same goes with pi over 4, which is a radian way of representing this degree. Pi over 4 is simply 45 degree, and pi over 3 is also 60 degree. Just 180 divided by 3 and you get 60 degree. So this is the radian way, or this is a way of representing the special angles in radian. In our next video, we look at some trigonometric identities and how to prove each of them.